Hey, it's Professor Hendricks, and today I'd like to talk a little bit more detail on lists, but also introduce a new data type called a tuple. And what exactly is a tuple? It may be best illustrated by an example. So let's just first enter the Python terminal and clear my screen. And let's say I defined two lists, L1, and maybe it's explicitly defined as a list of strings, in this case, single character strings. And L2 is explicitly defined as a list of ints. Now, there's something about the correspondence between the first three letters of the alphabet and this first three ints here. So maybe I want to combine them into one list that sort of captures that correspondence. So what if I did L equals zip of L1 and L2? Now, zip is a special function in Python, and what it does is it does exactly that. It merges two lists and it links up the elements one to the next in an orderly fashion. And so if I type L here, I see that it's not a fully realized list. It's still a zip object, similar to range. So in order to convert it to an actual list, what I need to do is use the list function. I can go back up here and do list of zip. And see, L is indeed a list of elements, and each of these elements is in some sense a package of two elements. And so that's kind of like how I like to think of a tuple. It's a packet of multiple smaller data types in this instance, and a tuple is typically not mutable. It's not changeable, and so we can't alter one of the elements of the tuple. And there's a lot of limitations in the features that it has compared to lists. And perhaps the reason for that is because by removing those functions, you get a more agile, more easily defined object. Let me just clear my screen. And how would we actually go about creating a new instance of this data type? So just as L1 in that previous example can be defined like this, and we define the type of that particular element, L1, we can see that this particular element, L1, is a tuple. And so that word tuple is the word for the data type, and it is also the word that can be used to create an instance of that data type, as with pretty much every data type that we'll see. So similarly, you can use just a pair of parentheses. So you can see that the pair of parentheses in some sense is analogous to the pair of square brackets in the case of lists. So for example, L here is a list, and each of the elements is a tuple as indicated by the pair of parentheses. One important thing about the tuple is that it is not mutable, it is not changeable. So for example, if I created a tuple that was my lunch, and maybe it had a sandwich, and maybe it had a chips, and maybe a soda. And I say, well, wait a minute, I actually want to have an apple instead of chips. Maybe I can just go ahead and do something like this. And it turns out you cannot edit the elements of a tuple because it is not mutable. And similarly, if I did lunch.sort, you can see that that sort functionality is not built into tuples either. So tuple is kind of like a streamlined, simplified version of a list with limited functionality. But there is a workaround. So given that I have this tuple lunch, what I could do is I could do lunch list and convert it to a list. And now lunch list is a list. And I should be able to modify an element of this list to convert it to apple and confirm that it looks the way I want it. And maybe if I want to be really healthy, okay, fine. I'll convert the drink to a glass of water. And then I can confirm there's my lunch. So what I'll do now is I'll convert this back to a tuple, and lunch of tuple of lunch, if I can spell, lunch list, and there it is. Lunch is a tuple that has been modified, but I needed to have an intermediate list in order to do that. And so tuples have other uses, and so you notice that I was able to create this list, and it was basically a list of tuples And you can start to use your imagination as to what that could turn into. You could have a list that could correspond to, say, the orders incoming to a restaurant, or list of students in a classroom, for example. So the possibilities are endless. And so because these tuples can have multiple entries, they could have multiple pieces of information. So for example, I might want to define something that's a list of exons. And so maybe my exons has, I might want to append to it a tuple that has the chromosome number, and then maybe a start position, just some random position here, and then I don't know, some other end position. I'm just making stuff up, but you can imagine appending multiple genomic positions to this, just some random numbers here. And for example, you can imagine storing an entire gene model, a list of exons for that gene, in a list of tuples. And in fact, I often do that myself. I might have a data structure that organizes exons in that way. And so the advantage of that is it can be sorted, it can be organized and kept track of. And there are other fancy ways of organizing this type of information, and we'll get back to that next time, and I'll see you then.